Hey guys, and today I'm going to be talking about Vibrio cholera. And to start off my presentation, I just wanted to start by mentioning the history of Vibrio cholera. And an interesting fact is that it was discovered twice. First, initially by a man by the name of Filippo Pacini in 1854 in Florence, Italy. And this was around the same time that there was an epidemic occurring in London as well for cholera, and epidemiologists often like to correlate. There's controversy, but a common point, popular opinion, I should say, is that the reason that cholera was able to spread to Italy as well as other European countries was because of the Asiatic cholera pandemic that occurred from 1846 to 1863. Now, Pacini would perform autopsies on his patients that would die from this unknown disease, and he would perform histological examinations on their intestinal mucosa. And by doing so, he would then record and observe what he saw underneath microscope slides, and his notes were so detailed and meticulous that they were one of the major contributors to why 80 years later, after he had passed away, why he was still accredited with the discovery of cholera. Now, the second individual who who discovered V. cholera was by the name of Robert Koch, and he initially came into contact with Vibrio cholera in 1883 with a group of German scientists, and that was the same time in Egypt when there was an epidemic of cholera occurring, and they came into contact with the bacterium because one of the scientists within Koch's group had contracted the bacteria and died from it. Now, the group as well as Koch had decided to investigate and try to not to identify the unknown bacterium, and the difficulty at the time was just trying to obtain a pure culture sample because without doing so, they weren't able to conduct and run tests that were necessary. And before they were able to obtain per said pure cultural sample, the epidemic in Egypt would eventually end. And Koch would have his opportunity once again to come into contact with the bacteria when there was an outbreak in India in 1884, and that would be the same time when he would eventually identify and be accredited for the discovery of V. cholera. Now, the epidemiology of V. cholera. V. cholera was has around 1.3 to 4 million cases a year, and of those cases, around 21 to 143,000 people die a year. And in countries such as America and other countries that have adequate levels of sanitization, you don't really see higher prevalence rates of the virus because we put things in our pools such as chlorine and we have filtration systems in place in order to prevent contaminated water. However, that is not the case in poor third world countries that have lower and inadequate sanitization standards. In countries such as these, this is where you start to see higher and more prevalent cases of the cholera. Now, the causal agents. Cholera is a gram-negative bacteria that is bacillus in morphology and is a non-invasive pathogen. And this photo to the right is a microscopic image of the bacterium. Now, the journal article that I wanted to discuss was on the cholera toxins and how they disrupt the barrier functions in the intestines. And within this within this article, they discussed the effects of cholera toxins, and it was determined that there was an increase in this and a term called adenosine monophosphate production, also known as CAM synthesis. And the increase in CAM synthesis inhibits this cystis fibrosis transmembrane regulators, and those are located on the apical membranes of intestinal cells, epithelial cells, and those are responsible for mediating transepithelial salts as well as the liquid movement. And in combination of the inhibition and communication of the cells within the system, as well as the fact that cholera toxins attach to the epithelial cells and increase the rate of which water can be released from the cells, greatly affects the rate of which individuals expend water. Now, in terms of transmission and pathogenesis, cholera is spread. It's like as mentioned prior, it's a non-invasive pathogen and can only be enter the host through ingestion of contaminated substances such as water or consuming contaminated food, as well as coming into contact with an individual's fecal matter who is infected with the bacteria. And the problem at hand with cholera is that it's clear in appearance. So if it were to be in water and it were to contaminate the water, an individual drinking that water would have no idea until it's too late because the water is clear. Cholera has the ability to withstand gastric juices within the stomach, and that's why it has the capabilities of attaching itself and affecting epithelial cells in the intestines because of two capabilities that it has. The first being biofilm formation, and the second being that it can lower the rate of which metabolic activities occur within the bacteria in order to withstand harsher elements. Out of the over 200 different types of serogroups of V. cholera, there are only two in particular that produce the cholera toxins that create symptoms and effects within a human host, and those are the O1 and O139 serotypes. And non-versions of this strain are causative of the disease. However, the non-strains can only create heat-stable endotoxins, whereas the O1 and O139 serotypes can create the more significant virulence factors, such as an increase in the expenditure of cellular water. And the way that V. cholera works is that it binds to GM1 receptors in intestinal epithelial cells, and afterwards it gets transported to the endoplasmic reticulum, where it activates onto the subunit A and binds onto the host subunit, and that causes ADP to be transported to the alpha subunit, and that stimulates the production of G proteins and increases the concentration of previously mentioned salicylic adenosine monophosphate CAMP, and that CAMP increases the epithelial release of water in those intestinal lumen, and the increase of water results in symptoms such as profuse diarrhea, thirst, leg cramps, and irritability. And all of those symptoms can be caused due to inadequate levels of hydration. And in terms of hydration, the best route of treatment for Vibrio cholera is oral rehydration. However, in severe cases, the use of antibiotics can be used, and the way that antibiotics affect V. cholera or affect the body is that antibiotics reduce the amount of fluid requirements as well as reducing the duration of which the illness would occur. And as well as in addition to antibiotics, IV fluids may be used to help rehydrate the host in extreme situations. Now, in terms of prognosis, if an individual is adequately hydrating themselves, then there is more than an 80% chance that the individual is going to survive in an encounter with the bacterium. However, if an individual does not adequately hydrate themselves and is facing profuse amounts of diarrhea, the dehydration would result in an individual passing.